So yeah, hi guys, let us see permutations now. Okay, so what is a permutation? Permutation is an arrangement of objects or items in an order, taking some or all the objects at a time. Okay, so let us understand this definition by taking an example. So example, let us suppose we have 1, 2, 3 numbers in a set. Okay, so you are asked to find out how many 3-digit numbers can be formed using these numbers. So the numbers that are possible using these digits are 123, right? This is just a brute force. Okay, we are not applying any formula. And 132 is also separate, different number. And 213 is a different number. 231 is different number, and 312 is different number, and 321 is also different number. So these are the different numbers that are possible using these digits from this set. Okay, so what are these? These are permutations. Okay, so what is a permutation? Permutation is an arrangement of objects or items, in this case numbers, in an order, taken some objects at a time or all the objects at a time. Here we have taken all the objects at a time. That means we are given with 3 objects or 3 items, and we have taken all the objects, right? So if you see, we are just arranging. So if the arrangement is like this, then this would be some number, and if the arrangement changes, then this would be some other number, right? So here, if you change the arrangement, you will get separate new number. That means if you find out the number of permutations, then you get the number of different numbers that can be formed using these digits, right? And we shall take another example as well. Okay, so let us suppose you have 3 pants. And 2 shirts. So we have 3 pants and 2 shirts. Okay, so here the question is, how many ways you can dress up with these 3 pants and 2 shirts? Let us label them this is P1, P2, P3, and this is S1 and S2. Okay, so how many ways can you dress up? So let us find out how many ways we can dress up. We have 3 pants, right? So you can wear P1 with S1, that means this one, or P1 with S2, or P2 with S1, P2 with S2, or P3 with, in the first day you can wear P1 and S1. In the second day you can wear P1 and S2. Here the motto is you have to dress up in a different fashion. Okay, so in the first day we are dressed up with P1 and S1. In the second day we are dressed up with P1 and S2. And in the third day we can dress up with P2 and S1. In the fourth, P2 S2. Fifth, P3 S1. Sixth, P3 S2. Okay, these are the possible ways that we can dress up in a different manner. Okay, so as we have discussed now, P1 S1, P1 S2, P2 S1, P2 S2, P3 S1, P3 S2. What are these? These are all the permutations, right? These are all the permutations. So once again, permutation is an arrangement of items taken or objects or some objects at a time, or sometimes we'll take all the objects at a time. Okay, so I'll give you one more example. So there is a word called ROSC. So using this word, how many 4-letter words are possible is the question. So how can we answer that? So let us see this. So if you go by brute force, then you have to go like this: R O S E and R O E S, like that. You have to go by this method. And just now we have seen the tree diagram, right? So you will get number of cases with R and O as well, and S as well, and E as well. Okay. So if you go by this method, it will take so much time. So that is where we want to have a formula. So see here we are generating 4-letter word. That is why I have taken 4 bars. Okay. So how many ways can we select a single letter from a 4 letters is 4 ways. 4 ways in the sense you can select R or O or S or E. Okay. So those are the 4 possible cases. And here repetitions are not allowed. Okay. Repetitions not allowed in this case. Okay. You will see another example where we allow repetitions. Okay. So here we have got 4 ways, right? And once a letter is here, that means any one of these letters will be there, right? So that letter should not be repeated again in these places. So we'll be left with 3 letters. So you can choose one letter from available 3 letters in 3 ways. Okay. Likewise, if 2 letters are here in this place, those 2 letters should not be repeated here, because here repetitions are not allowed. So we can choose one letter from remaining 2 letters in 2 ways. Finally, we will be left with 1 letter, and you can choose that in 1 way. Okay. So these are the number of ways, or these are the number of words that can be formed using these 4 letters. So how many? 4 into 3 into 2 is 4 into 3 into 2 into 1. That is 4 into 3 is 12, 12 2 is 24, 24 ones 24. So 24 different words can be possible. Okay. So why did I multiply here? In permutations, whenever we use and, that means into. Whenever you use or, then that means addition. Okay. And these are the important points we have to notice here in the permutations. So see here, we need all the 4 letters, right? We need this one and this one. Remember, whenever there is and, we have to multiply. And this one and this one, right? So all the 4 letters are needed, because the question is how many 4-letter words are possible. So in order to be a 4-letter word, you should be having 4 letters. So you should be having this one and this one and this one, likewise. So wherever there is and, you should be multiplying. That is how we got 24. And if you go by this method, conventional method, so you will also be getting same 24 only. Okay. So better to use the formula, so that it will save some of your time. Okay. And in the competitive exam, it is all about the time saving, right? And let us see the formula of permutations now. So formula of permutations is given as NPR. Okay. That is n factorial by n minus r factorial. So what do I mean by NPR? So NPR means you have n different objects and you have selected r different objects at a time. Okay. And you are arranging those r objects. So the number of permutations or the number of arrangements is given as n factorial by n minus r factorial. Okay. So let us understand this by taking an example. Okay. So in the previous example, we have seen that we need to form a 4-letter word. Okay. 4-letter word. So how many ways can we fill this? 4 ways. Because you are choosing only one letter here from the available 4. So let us suppose there are n different items. So Let us suppose this is I1, I2, I3 and so on. We have n different items. Okay. So here we want 4-letter word. Here we want R letter word. So we want R letter word. Likewise, we don't know what is R, so that is why this is first, second, 2, 3, 4-letter word. So this is 4, 5 and so on, R letter word. Okay. So how many ways can we fill this? See, compare this one. We have 4 letters and we want to choose one of them. So choosing one from 4 letters can be done in 4 ways. What are the 4 ways? R one way. You can choose R or O or S or E. Remember, when it is or, then that means plus. So we have 4 ways. Here also, you need to select only one letter here, right? This is for now. Eventually we find out the R letter word. Okay. So for this case, you need to have only one letter from the n different items. So how many ways can you choose one letter from n letters? Is n different ways. And the second one, so here the second one, since repetitions are not allowed, we have only 3 ways here, right? Because the letter which came here should not be again repeated here. Okay. So that is why we are left with here n minus 1. Here it is 3. Likewise, here it is 2, here n minus 2, and it goes on. Okay. So what will be the value here? Here it will be n minus r minus 1. How did I get that? See, here in the first one it is n minus 0. In the second one it is n minus 1. The third one it is n minus 2. So in the r it will be n minus r minus 1. So if you put 1 in the place of r, so that will be n minus 1 minus 1 0. That is n. So that means first place n. So the total number of different words possible, or the number of permutations, is given as n into n minus 1 into n minus 2 into and so on up to n minus r minus 1. Okay. So again, why did we multiply? To form a r digit word, you need to have all these letters. So you need to have this one and this one and this one. Likewise, there is and here, so that is why we are multiplying. So these are the number of different words that are possible. Okay. So that means, so this is the value. So these are the number of ways possible. But here it is mentioned that n factorial by n minus r factorial, right? So let us see the value of this, if the value of this one is equal to this one or not. Okay. So what is n factorial? N into n minus 1 into n minus 2 into n minus 3 into likewise up to 3 into 2 into 1. Okay. So if you are new to factorial concept, here is the definition. So 5 factorial is 5 into 4 into 3 into 2 into 1. That means from n to all the way up to 1. What is 6 factorial? It starts from 6. 6 into 5 into 4 into 3 into 2 into 1. What is n factorial? N into n minus 1 into n minus 2 into n minus 3 into n minus 4 into likewise 3 into 2 into 1. That means it will start from n and it will continue up to 1. Okay. And what about n minus r factorial? N minus r factorial also the same. N minus r into n minus r minus 1. Okay. Likewise, we multiply up to we reach till we reach 3 into 2 into 1. Okay. So if you find out the rth term here, what will be the rth term here? So let me write that one. So we don't know r, so that might be n minus r, n minus r minus 1 and so on up to 3 into 2 into 1. Okay. So if you see this one and this one, these are common, right? So you can cancel out these ones, right? So sorry for this mistake, n minus r minus 1. Okay. So you can cancel out these terms, right? So what we have left, n into n minus 1 into n minus 2 into n minus 3 into, and what will be the term before this? This will be n minus r plus 1 will be the term before this. So this is left, and we got this one. So if you elaborate this one, n into n minus 1 into n minus 2 into and so on. So just elaborate this, n into n minus minus into minus plus 1. So we got the same result like this. Okay. So that is how we prove this one is equal to this one. Okay. So finally, permutation is an arrangement of objects or items in an order taken taken some objects. In this case, we have taken r objects at a time. Okay. And the formula is npr is equal to n factorial by n minus r factorial. So what does this say? We have n different objects, and we have taken r different objects at a time, and the number of permutations or number of different words possible according to the question. Okay. And the number of arrangements done is given by this formula. And we have seen the number of arrangements or the permutations possible is this, and this one, if you simplify this one, you will get this one only. Okay. So the permutation formula when repetitions are not allowed is given as npr n factorial by n minus r factorial. So this is when repetitions are not allowed. So permutations when repetitions are allowed. So if repetitions are allowed, so let us see this case, because this is a new case for us. So let us take the last example. We have ROAC. So we want to have other words having these 4 letters only. Okay. So if repetitions are allowed, in the last case we have seen like this. So if here repetitions are not allowed, so for the word rose we have letters R, O, S, E. Okay. So we can choose one letter from these in 4 ways here. So once a letter is here, that should not be repeated anywhere here. So that is why we are left with 3 ways. Choosing one letter from 3 letters is done in 3 ways. And the next, likewise, here we are getting 2 letters. So those 2 letters should not be repeated here again. So that means we are left with 2 letters. So 2 ways and then 1 way eventually. Okay. Likewise, if repetitions are allowed, so we can choose one letter from the 4 letters in 4 ways, right? So in contrast with this one again will be having 4 ways. How? Because now repetitions are allowed, right? So that is why again all the 4 letters will be available for us. And again 4 and again 4. That means 4 to the power 4. Here it is 24. 4 to the power 4 means 16 into 16, that is 256. So if repetitions are allowed, then see how many number of 4 letter words are possible. So likewise, in the earlier example, we have seen this one as n into n minus 1 into n minus 2 into and so on up to n minus r plus 1. This is the value of this. So if here we are allowing the repetitions, right? So let us take same example, I1, I2, I3 and so on up to we have n different items. Okay. So now since repetitions are allowed, up to how many bars we have to draw here is r number of bars. Okay, because we are selecting r items at a time. So the first bar can be filled in n different ways. Second one n, like this one. Third one n, fourth one n, because repetitions are allowed. That means for the second letter, again you will be having all the items, and the third you will be having all, fourth you will be having all. Likewise, it will be n for all the r items. So that means number of permutations is given as n power r, right? Because n into n is n square into n is n cube into n is n power 4, n power 5, 6, 7 up to n power r, right? So this is a formula for permutations when repetitions are allowed. When repetitions are not allowed, then this is the formula. Now we have n objects and we have selected r objects at a time, and the number of permutations is given as n power r when repetitions are allowed. When repetitions are not allowed, then this is the formula. Okay, so this is regarding the introduction of permutations.